Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to be looking at the direct inputs or asynchronous inputs of flip-flop, of the D flip-flop and the JK flip-flop. And these are called set and reset. And essentially, if you activate the set input, it will turn the storage of that flip-flop to a 1. Now, the thing that's interesting about it is that it is not tied to the clock, and so that's why it's called an asynchronous or direct input, is that at any point in time we can activate the set and reset, and the set turns it to a 1, the reset turns it to a 0. And so this can be useful in situations where we want to count, where we don't want to count all the way up through the whole range of values that can be held by the bits that we're using. But we can do a count that is a smaller subset of that, and so we want to understand how these work, and that's what this video is about today. So let's get started. All right, so if you look at the schematic diagram of the flip-flops, and here is a D, we'll notice that there are two inputs that are on the top and the bottom. And the bottom one is the reset, and the top one is the set. And so essentially, if I look at that flip-flop and I connect an activating signal, in this case a 1, to that set, it will turn the value stored in here to a 1. And if I send an activating signal to the reset, it will store the value inside to a 0. Okay, and so this goes whether it's a JK flip-flop or a D flip-flop. Now, one thing I do want to point out is how do we know if we're activating? Remember, there's active high and active low inputs. And so these are active high. And so to activate them, I have to put a high signal in. So if I had active low, we can recognize those because they have a bubble. And so in that case, I would need to put a low signal in to set this to a 1. And sometimes people find this a little counterintuitive, that you would use a 0 to set to a 1. And then the same thing on the reset. If I had an active low input, then I would use a 0 because that's activating that input with a 0, and then we'll set that to a 0. Okay. An interesting little connection that some people make is that the bubble looks like a 0. And so we can activate the bubble with a 0, and so the active low inputs are activated with a 0. Okay, so what I'd like to do is go and just demonstrate this in Multisim Live. So let's go ahead and switch over to that circuit. All right, so let's place a couple of D flip-flops in here. And what we'll have them do is we'll just go make them like a shift register here. So I'm going to add that, and I'm going to need one more here, and an inverter. Okay, good. So we'll have this D coming in, and then we'll pass that D to the next one. We'll use this as a clock and make it synchronous, and then we'll display these on our digital probes. And on the last one, I do need a connector, otherwise it won't let me do it. At least I don't know how. Okay, great. All right, so if I want to now, at this point, I could there we go. All right, so we should be getting the data here. Okay, so we got 0 and 0, and let's see, I should be able to scroll this a little bit. All right, here we go. There we go, that's good. And then let's go ahead and put a 1 in here. So if I clock it, we'll get a 1 on the, the green input there, or the green flip-flop. And I clock it again, we'll get a 1 on the blue. So we can see their values here over time, and that's what I wanted to show you in this. So I'll go ahead and stop this, and we'll look just at the schematic again. All right, so let's look at the set and reset. And so what we're going to do is connect this input. So these are both active high inputs. And so what I'm going to do is connect the first one to a set, and then the reset of the second one. So if I were to activate this at this point, have it be a 1, it's going to set this first one to a 1 and set this second one to a 0. And then I'm going to use this inverter to just make sure that the other side is not activated. So these are opposites of each other. So it is, we never want to activate both at the same time, because that would be trying to set and reset, and then we'd get into an error state, and we don't want that. So, so here, oops, we're going to reset that guy and set that guy. So we're not going to do those. We're going to make sure that that doesn't happen. We're going to send them zeros on that. Oh, actually, no, I don't want those connected like that, because they will activate on the other side. Sorry about that. What I want is just to make sure that they're never activated. And in that case, I'm going to use another digital constant. And unfortunately, I can't preset it to 0, but we're going to set this to 0 right away. Once we get started. Okay, sorry about that. I don't want that to be connected to the other input. I want to be able to set that separately. So yeah, so in practice, you know, we could tie these to ground. Actually, let me do that. Let me just tie these to ground. Yeah, that's better. Okay, so now these will always be 0, because ground is 0 logic. So these will always be 0, so they won't be activated. So we can't reset the first one, we can't set the second one. We're just going to set and reset the first and second respectively. Hopefully you got that, a lot of the same going on. Okay, great. So what I want to do here is to start it, and what does it have a problem with? I don't care, it's okay. Oh, it does element oh, okay. I think it doesn't like the ground. Let's try this. Yeah, okay. All right, well, we'll put it to 0, which serves as a logical 0. That works fine. All right, so now I want to split it again so we can see what state we're in. So we're in a 1 for the first flip-flop and a 0 for the second flip-flop, okay? And that is the state that we set it to, you see? So it's being set right now. So I'm gonna undo the set, and now I will clock in some 1s, okay? So now they're both 1, 1. And if I just go ahead and at any point in time, you know, hit this, immediately it turns it back to 1, 0. And let's go ahead and put one more probe on here for the clock. Okay. And so now the clock signal, see, it's only going here, shifting those 1s, right? So the clock is not going, and yet we can still change the value of one of the inputs, one of the flip-flops, by doing this direct input. And so I reset the second flip-flop with that direct input. And so likewise, if I bring in zeros with the clock, Okay, so now we have 2 zeros for our state. And now if I go ahead and trigger the direct inputs, what we're going to see is that it sets it to its value 1, 0, because that's what we want to do. Alright, so that is an introduction to the direct inputs or the asynchronous inputs. I hope you found value in that video and that you maybe enjoyed it as well. I'm Mike Stanzik, this is Digital Electronics Classroom, and have a wonderful day.